Hello everyone, my name is Timothy Lee Grant, and today we are going to be continuing our path on learning Leetcode, trying to improve. So the way that I am trying to do the Leetcode methodology is I'm going to be sticking with one topic, and each Sunday is normally the day that I try to go and really learn five or four or three, whatever, however many I can during that time, problems. Try to write it down, try to understand it, not try to solve it. That's not the point, is to solve it. No, no, no. The point is to go and understand those problems. So go very quickly to the answer, figure out where I'm stumbling, what my problems are, and just iterate upon that. So right now we're doing 2 pointers or sliding window, and I went over the 3 problems that I did on Sunday yesterday. So I went back over them yesterday, and I was able to get all 3 of them, which is a good sign. But one of the questions that I'm having is, well, am I just memorizing the solution for those 3 problems, or am I generalizing? So I'm gonna be doing a problem in sliding window that I've never seen before, and I'm just gonna try to make some observations. So during this Leetcode process, one of the things that I'm trying to do is learn the specific problem, then generalize it. Okay, so once I do the specific problem, I'm also learning when I see multiple problems in the same area together, all sliding window, I'm able to generalize, okay, well, I've seen these 3 to 5 problems. What are their commonalities? How is it operating? What kind of things are they solving? Then, going back even further, kind of a meta analysis, I'm looking at my process for learning. So this video, I'm going to be doing a problem that I've never done before, and it's in sliding window. I'm going to be trying to make observations about my process itself. So that's kind of what we're going to be doing. All right, what should we... Arithmetic slices? Sure. Okay. So, let's see how it goes. All right, number 413, arithmetic slices. An integer array is called arithmetic if it consists of at least 3 elements and if the difference between any 2 consecutive elements is the same. Okay, so for example, 1, 3, 5, 7, 9, and 7, 7, 7, 7, and 3, -1, -5, -9 are arithmetic sequences, okay? Given an integer array nums, return the number of arithmetic subarrays of nums. A subarray is, oh, here's a key word. A subarray is a continuous sequence of an array. All right, so one of the observations that I made in my previous video when I was looking at, okay, well, I've done this specific problem, I've done this specific problem, I've done this specific problem. What are the commonalities? They're all sliding window. What is the commonalities? One of those things that I identified and mentioned was, okay, well, we're operating on arrays. That's one. And in particular, sliding window is about continuous data. So it's a window of continuous subarrays. Here's a brand new problem. It's a continuous subarray. If I see that phrase, I should instantly be thinking sliding window. Okay, so that's a good observation. Now, I don't really understand what it's meaning by where at least 3 elements. Okay, if it consists of at least 3 elements, and if the difference between any 2 consecutive elements is the same. Okay. So 1, 2, 3, 4. The output is 3, and the reason is we have 3 arithmetic slices in nums of 1, 2, 3, 2, 3, 4, and 1, 2, 3, 4 itself. But why? So input nums 1 is 0. So each element or each array has at least 3, if not more elements in it. Okay. And let me try to read this again. An integer array is called arithmetic if it consists of at least 3 elements. Okay. And if, here's the second condition, the difference between, so difference is subtraction. So subtracting 2 consecutive elements is the same. And if the difference between any 2 consecutive elements is the same. So 1 minus 2 is going to be, oh, I see what it's meaning. 1 minus 2 is negative 1. 3 minus 4 is also negative 1. All right, so 1 and 2. So 1 and 2 is negative 1, and then 2 and 3 is negative 1. Is that the way that it's going? So 2 and 3, 3 and 4. Okay. If the difference between any 2 consecutive elements is the same. Okay, how do I want to do this? So I have an array, and I'm trying to find the difference between consecutive elements. So let me look at these as well. So 1 and 3 is negative 2. Then 3 and 5 is also negative 2. Okay? So 5 and 7 is negative 2. 7 and 9 is negative 2. Okay? This is 0. This is 0. This is 0. Okay? Alright, so this one is going to be positive 4. So 3 minus negative 1 is positive 4. So negative 1 minus 5 is positive 4. I'm starting to see the pattern here. Okay. Negative 5 minus 9. So that's positive 9 minus 5 is positive 4. Okay. So my window is actually going to be 2 elements. Okay. And so I'm trying to find how many, like, okay, so I kind of understand what it's meaning by the difference now. So given an integer array nums, return the number of arithmetic subarrays of nums. So a subarray has 3 elements, and each one follows that So now I'm trying to figure out how do I actually isolate these separate lists. This is definitely, so going back to the meta, this is definitely something which is different than any of the other problems which I was doing, but it also is a little bit similar because in the sliding window approach, each time you're doing a different way of kind of analyzing the window. So sometimes you're summing it. Sometimes you are like doing a continuous summation of the window. So you're minusing what you kick off and you're adding what you're grabbing onto. Sometimes you're putting the window into a set, right? And so that's kind of what I'm thinking. Maybe I'd have to take this window and like put it into a set. So put it. All right, so the answer's not coming to me very easily right now. I'm going to go directly to the solutions. So, by calculating consecutive differences, we can group and count all valid arithmetic subsequences of length larger than 3 using triangular math. Okay, so right now what I'm trying to figure out is I stumbled on the fact that I didn't know how to break these lists up into the way that this problem wanted. So now I'm trying to figure out like, okay, well, I know how to determine if the if the window has a difference of the same as the other window, right? But how do I use that to build a grouping of lists that could be 3 elements, but also could be 4? And if you noticed, it was like a subset of a larger and then of a larger list. So approach 1, 2, 3, 4, 5, same difference here. Plus 1, plus 1, plus 1. 2 slices, count. Okay. Check if the array has fewer than 3 elements. Return 0 if not. Yeah, that makes sense. Compute the difference array D. Okay, group consecutive differences using group by. For each group of size larger than 2, count slices using that? Okay. I don't know what this group by is. Okay, so if we don't have 3 elements, there's 0 elements with, or 0, we can't do that operation. So that makes sense. So D equals a list of nums plus of I plus 1 for I in range. Here. So what are we doing in this section? We are creating a list, which is what? It is the differences between that element and the element that comes immediately before it. Okay. Okay. So for blank in group by D, Okay, let's look at a different solution. I want to find, is there like a actual sliding window here? Sliding window algorithm. Okay, here we go. Initialize a diff variable with difference of the first two numbers. Iterate through the array nums. If difference is equal to the increment, count till the length is greater or equal to 3. If difference is changed, then change the left and difference variables. Okay, so we get the length. If the length is less than 3, we return 0, yeah. So C is 0. Our left pointer is at 0. The difference, so I think this is array, element-wise array subtraction. So no, it's not. It's not like, never mind. We're just doing the 0th index minus the first index. So we're just getting that element minus the element above it. Okay, so for right in range, starting at 2 and going to n, if nums of right minus 1 does not equal difference, so if we have a new difference, then we change our left, so we update our left to be here equal to our right, minus 1, and then we calculate that new difference, okay? And then we skip all of the rest, okay? Otherwise, we set this temp equal to left. Huh. So they're not even building a set of actual lists. They're directly just counting. I was thinking about this completely different. I was thinking, okay, well, I'm going to build the actual lists of those arrays, and then I'm going to count the size of my set. Okay, they're not doing this. So there's some connection between whatever is run in this while loop and how many arrays there's going to be. While right minus temp plus 1 is greater than or equal to 3, so I think this is because, so we're taking, let's say, so left is at, I think I see what's going on. So left is at, let's say the second index, and right is at the 10th index, right? So we have a huge array. or a huge string which is all having the same difference between them. Like this window is, all the differences are the same element. Well, now what I need to do is I don't actually want to move over my left, but that's why I create that temp variable here. So I'm just pointing temp to be equal to my left. Okay? Then what I'm doing is I'm just moving my left over until I get to 3 elements, and then I stop. And I'm increasing that C by 1 because each time that each of those is a unique sub-array because my right is being fixed. And if I have that 10 here, this is one unique sub-array. And then I move my left over by 1, or the temp over by 1. And now this is a new unique subarray because it starts here again. I didn't move my right, but I moved my left, and now there's only 9 elements in here. Okay. And then I move my left over again. Now there's only 8 elements, and I kept my right fixed, and all of these in here still have the same difference. And then I do that until I get to the length is only 3 elements, and I say, okay, well, once I've counted that 3 element wise array, then I need to stop, and now possibly I need to go and move my right over by 1, and my actual left is still pointed way over here at this one. This was just the temp that moved over. So now I moved my right over by 1, and now I'm going to check again, hey, is my difference still equal to what it used to be? If yes, then I do that. Now I have 11 elements in my array, and my right pointer is all the way over here at a new element, and I have to go all the way, and each time capturing a new unique array. But if I move my right over by 1 and the difference changes, well, okay, hold on. Now all of these other values are no longer it. We have to move our left pointer all the way over there. So intuitively, I can kind of comprehend what's going on. I would have never figured this out, by the way. Can I write it myself? I doubt it. Because there's a lot of things that I'm thinking right now are going to trip me up. This 2. Why does it start at 2? I know the answer is something to do with just like, well, we already counted the first window or something like that. Like here's a 0, here's 1, and now the next one is 2. But I haven't convinced myself about that yet because I don't understand how that window is going and all of that. So the other thing is like, okay, so if the difference is not the same, then we update y right minus 1. Why not put it equal to right? Y minus 1? Oh, because we need to create a new one? No, that doesn't make any sense because I'm not even using left in this calculation. So why? And what if there's never a difference which is the same? Where are we increasing right? Oh, well, right gets implicitly increased. Okay. So still, I'm not convinced of it. I need to go into this problem again. I need to do my journaling. I need to write out exactly what's going on, and I need to investigate this one. Okay. I would have never come up with it. So how did I abstract out the ideas? when I went and hardcore learned those three problems, which were sliding window, was I able to abstract it to this problem? And the answer is, well, I did pick up on those keywords, and I did kind of understand that there was going to be a sliding window. I was thinking about the sliding window kind of different. This one is more of the jaggered sliding window approach because you're fixing your left, and each time you move the right over by one, and then if the differences are different, then you move your left over by one. And then this problem also has another kind of interesting thing is you can use this like temp variable to calculate unique identities within your window, which I had not seen in any of the previous questions. So I need to kind of look at that and remember like, oh, that's an interesting method that they're using. So I'm going to go back over this problem later. Try to learn it, try to get more of a intuition of it and convince myself of what's going on here, and then see if I'm able to kind of code it out myself. But yeah, that is I'm gonna actually just take this and submit this so that I have it on record. Okay. Oh, I should have like commented. This is not my code. I need to go over it so I can understand the concepts. Okay. I'm going to submit that again so that I have that in my record. That way I can come back to it and kind of know what I'm up to. Okay. I can't consider it a success. I also can't consider it a failure. I don't know. I'm still just going to be trying to figure out how I can move forward and improve on my Leetcode and try to continue to tweak my process and go through as many problems as I can, understand as many problems as I can. And as I said with the Leetcode now, right? Like this is my world that I'm living in right now. The entire map. I'm just in this little domain, so I'm trying to learn these two concepts and then later try to branch out. But we'll see what's going on. I will continue to post videos, post updates, and try to take you guys along in this journey of doing Leetcode. So if that's interesting to you, subscribe. That would be awesome. I hope you guys have a wonderful rest of the day. My name is Timothy Lee Grant, and I'll see you guys in the next video.